Time's out, and we are starting again with our day, and a new session is about to begin. I am utmost glad to now call on stage, on the master stage, Mr. Marcel Taubert, VP Defense and Space at Secunet Security Networks, our sponsor. Welcome on stage for a talk entitled From Design to Deployment, Cyber Sovereignty for Space-Terrestrial Network. The floor is all yours.
Thank you. So, good afternoon. I hope lunch was good. You had time to digest a little bit because the next 20 minutes will be heavy. But I wouldn't be on this stage if I didn't believe that we can deal with what I'm going to talk about. So, a short personal note. I joined the Navy in 2002, straight out of school when I was 18. And it felt like an adventure for me. But there was a second reason, one I wouldn't only fully name now years after. I wanted to live in freedom, and I was willing to defend it. But when I joined the Navy, the Germany we had still felt like a completely different country. So a few years earlier, our former defense minister, it was Volker Rühe, had said something that captured the mood of my entire generation. He said, for the first time in our history, Germany is surrounded only by friends. So now, 24 years later, the quote is still correct formally, but the world has changed dramatically. So in the Navy, I learned the craft of war. I learned what it means to depend on technology at sea and what happens when the satellite link fails. So counter-piracy and cybersecurity became my fields. But the time I left after 13 years in the Navy, cyber had become the operational reality of every domain we are in, including space, of course. Today, I lead the Defense and Space Division at Secunet. And we build and operate classified IT systems for the German government and for our EU and NATO allies. So everything I'm going to tell you now comes from that line of experience and not from policy papers. So let me give you one sentence I want you to carry out of this room. And Europe's digital freedom isn't given, it is kept. And keeping it is an architectural choice. That's not a summit declaration, it's not a funding line, and it's not just a slogan on that slide. Keeping it is an architectural choice, made by engineers, fielded by operators, and it is verified under contested conditions. So, which brings me to a question I want to leave open for the next 20 minutes and answer at the end. So, what does it actually mean to be a guardian of something? I learned what it meant to be when I was at sea, in a Germany that thought it was surrounded only by friends. And today, my work is different, but the principles are still the same. That is my frame. So, for a long time, when we talked about space security, we meant one thing: protect the satellite in orbit. That was a picture, and I think it was a useful picture, but as we learned this morning, it's not longer the whole picture. So the satellite is only one node in a chain that runs from the orbit, through the link, through ground segments, often in 3 or more different national jurisdictions, through terrestrial backhaul we do not control, all the way to the terminal in the hands of an operator who needs the answers in real time. So if you defend one node and the chain has 9 others or something, you do not have a defense, you just have a slogan. And space security is no longer about protecting satellites. Space security is about whether the entire communication chain behind a mission can be trusted under pressure. So let me make this concrete. Yes, there are threats directly in orbit. We learned today, and in 2018, the good example, a France defense minister publicly named a Russian satellite, Olymp K, that had approached a French military communication satellite and tried to intercept its transmissions. So imagine a NATO defense minister on the public record stating this. But that is not where the bulk of operational pain has come from. I think the bulk hits the ground, the link, the terminal. We had this example before lunch, February 2022. A piece of destructive malware called Acid Rain is rolled out, not against the satellite, but through the management of the CYSAT ground segment. So tens of thousands of Viasat modems across Europe are bricked within hours. Ukrainian military communications go dark exactly when they shouldn't. And as a side effect, the remote monitoring of nearly 6,000 wind turbines across Central Europe fails, and mainly in Germany. No missile, no wiper, just a wiper, sorry. No missile, it was just a wiper through a misconfigured VPN. So that was the warning. And in January 2026, since the 8th of January, large parts of the Iranian civilian population have disconnected from commercial LEO connectivity. So Starlink terminals across the country degraded. Over 1,000 cumulative hours of effective denial, and Western intelligence attributes the technique to GPF spoofing and Ku-band jamming equipment of Chinese origin. So Russia has been jamming Starlink in Ukraine now since 2022. But Iran is different in two ways. First, Iran is denying its own civilian population, not soldiers in a war zone. And second, it is sustained. So over 1,000 hours nationwide with no rapid counter from the operator. That is the new operational reality we have to face. And I truly believe it will not stay confined to Iran. So the threat environment isn't about an abstract slide. It is 1,000 hours of denial. It is a wiper through a VPN. It is a Russian satellite naming a French one its target in orbit. And every one of these incidents shares the same pattern. The attack doesn't come from orbit alone. It comes through the trust we misplace. So look at what is converging right now. Space systems, governmental networks, commercial constellations, terrestrial, we have 5G, 6G, 4 layers fusing into one hybrid network. And that convergence creates capability. It also creates one very practical question. And the sovereignty question has moved. It is not longer, do we own the satellite? It is now, do we control the trust? So who issues the identities? Who manages the keys? Under which jurisdictions? So subject to whose laws? And if trust is the category, here's what it looks like in practice. I think there are 6 core controls, beginning with identity. Who is on your network? Keys. Who generates, distributes, and revokes them? Trust anchors. So hardware security modules and crypto controllers under European control. Software integrity. What runs on your device? Verified with software bills of material. So the Cybersecurity Act makes this as a law from September. Administrative access, so the people who configure the routing, the logs, and everything under your clearance. And last but not least, the supply chain, so where your hardware came from, who had access during manufacturing. 6 controls. Today, Europe controls, at best, 3 of these 6 in space communications infrastructure, and I will let you decide which of these 3. So, sovereignty is not what we declare, it is what we can build. What we can control, and what we can use under real conditions. So, one more architecture point before I show you what we have built. It's about post-quantum cryptography. Post-quantum is not a future problem. It is an architecture problem we have to solve now. For systems we are deploying now. The standards for it, NIST has published them, so the standards are not the problem anymore. The problem is life cycle. a satellite terminal, a Xena box, a key management appliance. These are systems with 10 to 15 years operational lifetimes. And you cannot ship a product today that requires a hardware refresh to accept tomorrow's algorithm. So the first question we ask on every architecture review is no longer which algorithm, it is the crypto stack pluggable? And at Secunet, we are already running classical and post-quantum algorithms side by side into our Xena technology today. You do not rip out the architecture, you rotate the primitives. So that's the difference, what we believe is between a product and an architecture. So now to what we have actually built. Two things side by side, just as an example for today. What we are building for the next decade and what we are delivering today. So let me be open about something we are working on right now. It is called the Xena Layer 2 H100G. So on the first surface, it's a factor of 100 bandwidth increase, coming from 1G to 100 Gs. But that's just the headline. It's not the whole story. The story is that under the surface, 4 high technology projects are running in parallel. And all 4 have to succeed, or none of them does. So as an example, a completely new hardware design. We are scaling from layer 2 today to layer 3 in the next generation. So a completely new operating system, moving from a monolithic kernel to a microkernel-based architecture, component-based architecture in our own language. So, and a completely new operating system for the cards we are using, so for the highest classifications level, and a new crypto module. In previous generations, crypto modules were just an add-on. In the new generation, it's the central performance enabler. So these are 4 parallel programs, years of foundational engineering, completion targeted for the end of 2027. And the reason that date matters? First reconnaissance satellite programs are already waiting on this technology because the bandwidth demand of processing space-based intelligence on the ground is growing exponentially. So that is what serious sovereign capability look like under the hood. Multiple disciplines converging at once. So no shortcuts, and that is the price of trust at the highest classifications levels. And precisely because this kind of development takes us years, we cannot tell the market to wait until 2027 or even longer. We deliver now through a cooperation with the one we have with CYSAT for the ARCA SATCOM VPN technology. And that is not a stopgap. That is the architecture of an industry that has to deliver today and in 5 years at the same time. So our Xena architecture has been the backbone of German and European classified networks for over 20 years now, from the restricted level up to NATO secret, EU secret. Operational classifications certified under real adversarial conditions. So it's an architecture that assumes that the adversary is competent, persistent, and already inside of your infrastructure. So then extending that trust model into space is a hard problem. So 600 milliseconds round trip in geostationary orbit. Intermittent connectivity, like link handovers between satellites, beams, ground stations. So every transition is a moment where a naive trust chain breaks. And what we have built together with CYSAT is a Xena architecture extended for satellite physics through the ARCA SATCOM VPN. It's latency tolerant, it's resilient to link interruptions, it's approved up for EU secret, operating over Starlink, OneWeb, any LEO constellation, or any satellite that can carry IP packets. So only one data point as an example. In one of our recent field tests over Starlink, the accelerated tunnel multiplied effective classified throughput by a factor of 7. One number, but the point is not the number. The point is the architecture is deployed. It's measured and it's working today. Not in 2023, 2030, sorry, it's working today. So while we build the next generation that arrives in 2027, we deliver the architecture that defends the next 24 months, both in parallel. That is what design reaching deployment looks like. And if you want to see it, not on slides, but on hardware, we have set it up. Well, we wanted to set it up in the boardroom next door, but now there are no windows, no LAN connection to the outside. Therefore, we had to be a little bit resilient and flexible. So if you're still interested, we will make a special show just for you outside. My team is waiting there with a beach flag outside the building, or come to our booth in the exhibition. We are happy to show you the showcase outside. And if you are interested, walk over to them, and after this keynote, ask a question you would ask of any operational systems. The answers are there. So one distinction before I close. We establish trust in networks that are themselves hostile. The internet, commercial LEO, foreign backhaul. So we provide a sovereign trust anchor on top of that. But trust isn't the same as availability. If a satellite is jammed, if a fiber is cut, confidentiality holds, but the link doesn't. So trust is architectural, availability is structural. And I truly believe mission assurance needs both of them. So one more reason this matters now. Boris Pistorius, our German Minister of Defense, had set the bar. He said the Bundeswehr must be war capable by 2029. And Bruno Kahl, the former president of our Foreign Intelligence Service, he said in front of our parliamentary oversight that Russia could be in a position to attack NATO states by 2030. And looking over the big overseas, thank you, our American partners, they watch 2027, because that's the year when Xi Jinping has reportedly directed the People's Liberation Army to be ready for a Taiwan contingency. So we have 2027, 2029, 2030. 3 years, 3 theaters, 3 stopwatches. And every single one of them is shorter than the typical European procurement cycle for a new sovereign communication capability. So if you are still wondering why our next generation architecture has to be finished by the end of 2027 and not 2031, this is the answer. We aren't building for a trend. We are building for a clock. And speed from design to deployment isn't an engineering KPI, it is a deterrence question. So a sovereign capability that arrives in 2032 doesn't deter the threat of 2027. It just documents it. So around 6 months ago at Secunet, we committed publicly to a claim. We are the guardians of Europe's digital freedom. And I had a part in that decision. I worked on the language. I argued for it inside the company. And let me tell you here where that comes from my side. My children, I have 2 wonderful twins, 9 years old, so they were born in 2017. And by the time they took their first breath, the Russian annexation of Crimea was already 3 years old. The war in the Donbass was already 3 years old. NATO neighbors had already lost territory. Soldiers had already died. We still called it peace. But it was a peace in which the assumption of my own generation had already started to break. My children, in other words, were never born into a peaceful world. We only called it that. What I can do for them is not peace. Peace is not in my hands. But freedom can be. And freedom requires cyber sovereignty as a precondition. Because without control over identity, over keys, over the trust anchors, freedom becomes an arrangement with someone else, not a property of Europe. So that is what guardians of Europe's digital freedom means when I say it. It's not a tagline. For me, it's a contract with a generation that will inherit whatever Europe we choose to build now. And a guardian that cannot deploy is not a guardian. It's just a spectator. So let me close where I started. Europe's digital freedom isn't given. It is kept. And keeping it is an architectural choice. From design to deployment, that is the gap we have to close. So one question, ask it of your own organization when you leave this room. Who controls your keys? If the answer takes longer than 30 seconds, you already have your answer. We at Secunet, we have made our choice. We are the guardians of Europe's digital freedom, and be the one who keep it. Thank you very much.
Thank you very much, Mr. Taubert. I've been writing down so many quotes. I think you could, yeah, impactful quotes. Thank you very much. We have one question from the room, and I invite all participants to scan the QR code and ask their questions or raise remarks if you want to jump on the conclusions that were presented here. But first and foremost, one question of Monsieur Arnaud Boisseau. I will display it now on the screen. We shall see it. Down to which level do you control the hardware of your new SINA? ASIC, microcomputer, RZM, ROM?
Yeah, that's a wonderful question. And the answer, it depends on which security level we have an approval. So we have technology that's approved up to the restricted level and up to the secret level. And for the highest levels, we control it to the hardware, where the crypto modules are produced in Germany. And of course, there are controllers not coming from Europe, because no one in Europe is capable to build these things. But we have a trust architecture around it that we can formally verify that the things we are doing are completely safe in the architectural environment.
Thank you very much. No more questions from the room now, but please do not hesitate to raise them using the application Connects Me. I really like what you said about trust being architectural. And we've been talking a lot about trust, but a topic that is often forgotten in such settings is that of the human factor. How do you address that?
Well, that's a very good question, because the human factor is that what breaks the chain mostly very easily. And therefore, usability is a part that we are addressing. So coming to all those systems, we are thinking in ecosystems. And everyone is talking about AI, about combat cloud and so on, but someone has to use these things, and that's the human behind it. And therefore, we are also building technology that has a capability of multi-session access. So if you have a solution that is used in the secret level, in the restricted level, probably completely unclassified, the user have to use 3 different systems, and we build it in one. So make it really user-friendly, helpful, that security isn't the pain, but more or less the enabler.
Thank you very much. Another question, maybe jumping again on one of your impactful quotes. You said freedom sometimes comes up to, well, settling arrangements with someone else. And installing Europe's sovereignty is one thing, but we talked this morning about converging standards, regulation, different also regional frameworks, regulatory landscapes. What is your take on that? Do you, for instance, as part of Secunet, contributed to the open public consultations of the European Commission on the latest directives and proposal of regulations?
Yeah. Indeed, we are trying to do this. And I truly believe in the European motto that we are united in diversity. But still, with standards, we are really struggling, because standards in the EU or in NATO, they take us 20 years or more to be completed as a standard. And therefore, I truly believe that we need minimum interoperable standards and not these standardization monsters. And probably that we have to trust the industry to go straight forward, because that's what we're doing here at CYSAT. We need ecosystems, we need partners, and I think industry has to take over more of the responsibility at that time.
Hear, hear. But then again, this morning we talked about the space sector being a triple playground, and awareness raising has sometimes to be purposed or to talk to those specific actors and what are their interests. In this advocacy part, how do you, at Secunet, raise a common interest or shape a common interest on those issues?
So the thing is, we trust in what we are very good at. So we are very good in high security solutions. We are very good in regulations. Still, we think that we have to solve a use case for the customer. And when new technology arises, we are going into that technology. So in Germany, we were the first ones who had a cloud stack that was approved to the national secret level. But to be honest, we had one customer. It worked, it was approved, but did it work like what you would expect from a cloud stack? Probably not that good. So we have to evolve and push things forward with technology on the usability side, and that is what drives us and where we can really help.
You've also, maybe one last question, you've also talked a lot about timing and developing technologies that would be of use now, but would also still be apt for the next coming years and threats we do not know about.
Yeah.
But what about past legacy infrastructures, satellites?
It's a very good topic because usually it's not so easy to fetch the satellite and put some new modules on it. So therefore, we truly believe that some of our solutions can work on those satellites. So if we can not upgrade a satellite, we have to use that capacity that is there and make a security layer in beneath. So that's a trade-off, but that's how some of our work is done. And if you're interested, it's part of our solution we have done together with CYSAT to use software as an accelerator even in untrusted and contested environments.
Thank you very much. And you've said you come from the military.
From the Navy.
From the Navy, indeed. Where do you think your sales would take you? And me personally, or Secunet at all. So I think we are on a very good track. So the claim we're talking, it's that what we are really striving for. And that's why we are here, and we would love to get in contact, in touch with you, because we truly believe in ecosystems, and that's our part of the mission for the next years. Thank you very much. We know that participants can come and meet you at your booth for an interactive session outside, given, well, connectivity is sometimes an issue in the building here. But please do not hesitate to come and look more closely at your work. Thank you very much for your presence, and thank you for sponsoring the event. A warm round of applause.